So the second demand elasticity, or third I suppose, but the second of the new demand elasticities is looking at the relationship between the price of one product and the demand for another. So this is called cross price, or just cross elasticity of demand. And for some reason, it's abbreviated by X for cross. X is a cross. I mean, quite why it's not CED, goodness only knows. But anyway, there you go. And what this shows is it shows the responsiveness. Again, it's the same type of formula, the same type of explanation as all the others. It's the responsiveness of demand, in this case, for one product, such as X, to a change in the price of another. So it's changing the price, of another good, a different one, say Y. Now, one of the big things that people get confused with about cross-elasticity demand is they think it shows how the demand for one affects the demand for the other. That's part of it, but what cross-elasticity demand actually measures is how the price of one good, changing, Y, affects the demand for a different good, X. So don't kind of go, oh yeah, demand, it's price of one, demand for the other. In formula terms, therefore, again, it works the same way as all the other formulae. It's the percentage change in the demand, in this case, for one product, like X, divided by the percentage change in the price of Y. And again, it can be elastic if demand changes more than proportionally following a change in the price of the other good, and it will be inelastic if demand changes less than proportionally following a change in the price of the other good. So if Y changes, if the price of Y changes by 10% and the demand for X goes either up or down by 5%, then that's inelastic. If the demand for X goes up or down by 20%, then that's elastic. So as you can see here, this is another one where sign matters, because what I'm talking about is the idea that we might get an increase or we might get a decrease in demand. So let's imagine we have a situation in which there is an increase in the price of one good. Let's stick with A and B. There's an increase in the price of A by 10%. What we're going to think about is how other goods might be related to A. And there are two basic ways in which they might be related. The most obvious way is B might be a substitute for A. So we can use B instead of A. In which case, an increase in the price of A, in the case of substitutes, an increase in the price of A, of course what that means is that people will buy fewer A, but because A is more expensive, then what's going to happen is that there will be an increase in the demand for B. Or, if A became cheaper, a decrease in the price of A, then people buy more A, and therefore they buy fewer B. So if we take an example, let's imagine that there is a decrease, let's take this one, there's a decrease in the price of Lindt chocolate, as a result of which there'll be an increase in the demand for Lindt, and as a result of which there will be a decrease in the demand for Cadbury. And what we can see is that the decrease in the price of one product has led to a decrease in the demand for another, and therefore cross-elasticity demand for substitutes will be positive. And that goes against your gut feeling, because you're kind of thinking substitutes, they go against one another. If I buy more Lindt, I'm buying less Cadbury, isn't that negative? I mean, it is, but it's the relationship between the price of one and the demand for the other. So likewise, if the price of Lindt chocolate was to go up, people would buy less Lindt chocolate, and as a result of which they'd buy more Cadbury. So it's the link between the price of one and the demand for the other. And we can see that there is a positive correlation between those things. If the price of one product goes up, you buy the substitute instead. Hence they rise and fall together. So what other relationship might there be? The other relationship, it could be that they're products that go together. They are complements. So classic example would be something like Xbox consoles and Xbox games. Or it could be Chanel dresses and Chanel handbag. Suppose that there is a decrease in the price of Chanel dresses, then people will buy more of those dresses. Yeah, there'll be a decrease in the price of dresses, leads to an increase in the demand for dresses. But as a result, since we all want to be accessorized, we can't have a Chanel, we can't have a little black Chanel dress without a little black Chanel handbag. That leads to an increase in the demand for bags. Or if there is an increase in the price of Xbox consoles, then people buy fewer Xbox consoles, and as a result of which they also buy fewer games. So in the case of complements, what we can see is that a decrease in the price of Chanel dresses leads to an increase in the demand for Chanel bags, or an increase in the price of Xbox consoles leads to a decrease in the demand for Xbox games. Therefore, we can see that cross-elasticity demand is going to be negative. So the basic idea then is, and again, it's negative. This is one people tend to think, oh, hang on, they're complements, they go together, it should be positive. But it's because it's the change in the price of one and the demand for the other. So, what's that got to do with, what we haven't talked about is actual elasticity. We talked about the sign, but what about the value? So, let's suppose that over here we'll have substitutes, and over here we'll have complements. And let's suppose that there is a decrease in the price of something by 10%. What sort of reaction might we get? So, if the complements are really, really close, something that's really well linked, two products that fit together particularly closely, then we might say, we get a very strong response. Suppose there is a big decrease in the price of cars, then you might say there'll be a big increase in the demand for petrol. There'll be lots more people. Driving cars and therefore buying fuel. So that's a strong relationship. So we might get a more than proportionate increase in demand. We might get something like a sort of plus 20% increase in demand. Sometimes complements might be weaker. So we might say, we get a decrease in the price of gym classes, as a result of which, people have to buy more leggings. It's no good going to gym class without your leggings. So a decrease in the price by 10% leads to a plus 5%, say, increase in demand. So here, for strong complements, -1 to minus infinity, remember it's minus change in price there, plus here, that gives us strong complements, whereas 0 to -1 gives us weak complements. It might be that two products are completely unrelated. So it could be that there is a decrease in the price of makeup, and the impact on the demand for shark cages, to keep you safe from sharks while swimming, there's probably no link at all. Therefore, cross-elasticity demand would be 0. In the case of substitutes, again, they could be strong and weak. So it could be that there is a decrease in the price of tea. How does that affect the demand for coffee? Well, if tea becomes cheaper, people buy more tea, therefore they probably buy less coffee, but probably not much less. They're not, they're substitutes, but they're not that close. So we might only get, say, a 3% change in the demand. Whereas you might say two products that are very strongly related might be, the price of BP petrol. Suppose there's a decrease in the price of BP petrol, then Shell petrol, people will switch away from Shell towards BP. There'll be a big decrease in the demand for Shell petrol. It might be 15% or something. So for weak complements, again, it will be 0 to +1. A decrease in price there leads to a small decrease in demand. But for strong substitutes, So that's weak substitutes. For strong substitutes, yeah, a change in the price of one leads to a very big change in the demand for the other, yeah, and in the same direction. Yeah, so that would be +1 to plus infinity. Yeah, so that's not particularly, that wasn't particularly well done. I'll re-summarise now. Yeah, so if we've got, yeah, so we said we could have complements, we could have substitutes, or there could be no relationship. Yeah, we said that if they're strong, then cross-elasticity demand will be between, yeah, -1 and minus infinity. Yeah, if they're weak complements, it will be 0 to -1. If there's no relationship, it will be 0. If they're weak substitutes, it'll be 0 to +1. And if they're strong substitutes, it'll be +1 to plus infinity. And like with cross-elasticity demand, like with income elasticity demand, they're all inelastic, whereas that's elastic and that's elastic, because the actual size of elasticity just depends on the degree of change, not the direction. And you can show that on a graph. So we could say here is the price of A. If an increase, and let's suppose the price of A rises from P1 to P2. We know that in the case of substitutes, suppose the price of A goes up. People don't buy A, therefore they do buy B. So we get that sort of relationship. Yeah? An increase in the price leads to an increase in the demand from QB1 to QB2. In the case of complements, two products that go together, an increase in the price of Chanel dresses means fewer people buying Chanel dresses, therefore fewer people are buying handbags. So an increase in the price, instead of that many bags, increase in the price of Jess, instead of that many bags being bought, demand falls to that level. So for complements, we get a relationship like that. For substitutes, we get a relationship like that. And in the case of makeup and shark cages, we say it doesn't really matter what the price of makeup is, the demand for shark cages will stay the same, and that would be no relationship. And that's basically what you need to know about cross-elasticity demand.